Assalamualaikum and hi. Today we are going to learn about Thevenin and Norton theorems. Right. For a figure A, the original circuit is a linear two-terminal circuits. Alright. A linear two-terminal circuit, that means is any circuit. Usually is a very big circuit, and then end of the circuit there is a load. Okay, basically a load. The symbol is impedance of L. This L refer to load. Alright, so from the original circuit, and then we are going to transform into Thevenin equivalent circuit. From the linear two-terminal circuit, we can remodel for VTH and RTH. Okay, RTH here is not RTH, but actually is a ZTH impedance. And then a similar end of the Thevenin equivalent circuit is a load. So load here again and again is impedance of L. Now what is VTH and ZTH? Okay, VTH is basically VOC. OC here is open circuit. Alright, ZTH is basically a combination series parallel, and then we need to calculate the impedance while we remove the V and I, which means the voltage source and current source. Very important thing is we need to know what is step to find ZTH and VTH. The first step is preliminary. The important things is we need to remove, right, the impedance of L. Okay, if the circuit is already removed, then we can omit this step. The next step is to find ZTH. Right, this is actually ZTH by setting all sources to 0. Sources here mean a voltage source. We set the short circuit. Current source is open circuit. Again, voltage source must be short circuit. Current source must be open circuit. The next step, we need to find the VTH. Okay, in order to find VTH, we need to return all sources to original positions. Okay, how to find the VTH? Yes, you can use any technique that you have studied earlier, which is if you like use a nodal, if you like mesh, and sometimes the circuit can solve very simple technique, maybe Ohm's law, maybe KCL, maybe KVL, maybe current divider rule, maybe voltage divider rule. So this is how you judge or you analyze the circuit. And then finally, the final step is draw Thevenin equivalent circuit. Okay, what about Norton? Okay, Norton basically we have the current Nortons, and also this is a Zn. Alright, and compare to Thevenin, Norton is basically a parallel circuit, and then it has a current. Alright, so I Norton also I short, ISC. SC here is short circuit. We will see later how we do an example, and then you know what this mean by I short circuit. So basically, what is the relationship between Norton and Thevenin? Actually, from the Thevenin, we easily can transform into the Norton equivalent using called source transformation. Alright, using a source transformation. Right, so from here you find a voltage source and ZTH. Alright, you transform using a source transformation for current source and Zn. Okay, this is a very important ZTH equals to Zn. ZTH equals to Zn. So this is a step how to find Norton equivalent circuit. Then we need to find Zn and In. Okay, the first step is remove ZL, and then we are going to find Zn. Okay, the voltage source will be short circuit, the current source will be open circuit. And then in order to find In in step 3, return all sources to original position, and then you need to analyze whatever technique you want to use. Maybe sometimes Ohm's law, sometimes KVL, KCL, sometimes current divider rule, voltage divider rule, sometimes nodal analysis, and sometimes maybe mesh analysis. And final step, we are going to draw Norton equivalent circuit. So here guys, okay, this is one example how to find Thevenin equivalent circuit and then find Norton equivalent circuit. Alright, at terminals AB. Alright, so from here, okay, from here, I do the start from Thevenin equivalent circuit. Okay, step 1. Is it necessary? No, because there is no ZL here, so I can skip this part. So I just proceed to step 2. Step 2, I'm going to find ZTH. Okay, ZTH, the voltage, right? This part we need to short circuit, right? So you need to redraw. This part is short circuit, resistor, inductor, and the capacitor. So here is your A, B, right? So this is minus J4 ohms, J2 ohms, 6 ohms. So where is the location of our ZTH? So here, ZTH. So from here, I can say this part, okay, is a parallel, right? Is parallel. So you need to calculate Z1 equals to 6 plus J2 parallel with then negative J4. Okay, I just give you a direct answer. You can calculate by yourself. So here is 2.4 minus J 3.2 ohms. So from here, the figure it look like this. Oops, sorry. Okay, this is our Z1. This is AB. ZTH. So this is 10 ohms. So from very simple this diagram, you can find ZTH. ZTH is Z1 plus 10. So from here, you can calculate the answers, right? The answers. So here is 12.4 minus J 3.2 ohms. Okay. We finish step 2. Now we are going to do step 3. Okay, I need to rub everything. Okay, let's do the step 3. Step 3, we are going to find VTH. Okay, in order to find the VTH, we must return everything in original position. Okay, the figure it look like here. Okay, so plus minus VTH, plus minus VTH. Now there is no current flows here. I equals to 0, so the voltage here is 0. Right, so the voltage across the 10 ohm is 0. So guys, I can say the location of the VTH, okay, the location of VTH is here. Okay, because of there is no current flows here. So what are the VTH for this diagram? We can use V minus J4 ohms. Alright, you can guess what this is, what the rule. J4 divided by 6 plus J2 minus J4, right? And then multiply the voltage, multiply 30, 20 degree volts, and then you need to work out, right? You need to calculate until the end, okay, until the end. So I believe that you can find the answer. The answer is here. Okay, so this is how we are going to calculate a VTH again and again. How to find VTH is actually depend on the circuit. Okay, for this circuit, yes, we use this rule. Okay, we are going to the final step. Draw Thevenin equivalent circuit. Step 4. Draw Thevenin equivalent circuit. So here is our VTH. VTH equals to 18.97, and then the angle is negative 51.57 volts. And then we have ZTH here. And don't forget the terminals AB. So ZTH is 12.4 minus J3.2 ohms. Right, so this is Thevenin equivalent circuit. Okay, now I'm going to draw the Norton equivalent circuit. Okay, let's rub everything. Norton equivalent circuit, we need to transform the Thevenin equivalent circuit to Norton equivalent circuit using a source transformation. So here is our IN, right? So this is our Zn. Okay, Zn value, yeah, Zn value here is 12.4 minus J3.2 ohms. So what is the value for IN? Okay, IN here, right here, IN is of course I equals to V divided by I is 18.97 negative 51.57 divided by Zn. So please calculate and then we can find what is your IN. So until here, we finish a little bit about Thevenin theorems and also Norton theorem. Okay, see you there. Okay, bye.